Hey guys, Parker here. Just here to present a quick little overview of the CForge teaching process. Again, this is my SIP project that is a teaching model that's based around feature-driven design principles. I'm just going to be going over a quick little lesson plan that is just one step in an entire CForge project. Now, to preface this, I want to say that this is not the beginning of the project. This is sort of a step in the middle of it. At the beginning of a project, the tutor and the student would collaborate and create two documents. The first is just a standard game design document that lays out what the game itself is supposed to look like, how it's going to be. The second is a feature list, as you can sort of see here, which is just an outline of how the order in which the features are going to be built for the project itself. So you can sort of see how it builds on each individual feature until you get a finished project. Each of these features is going to take the form of a lesson like this one, and will be collated into a document like this one before each tutoring session. One feature might take multiple sessions to complete, although the intention is to keep these feature development cycles as short as possible to allow for rapid iteration on the students' designs. So without any further ado, we'll just jump right into it. This first part is this lesson outline and scenario. It's mostly for the tutor's benefit. It just goes over, all right, what project is this? What is the philosophy of the project? What is the main thrust of it? Here, we just have a sort of generic arcade-style space shooter here. And just a quick little overview of what that's going to be. And again, that feature list that I mentioned, just to show how far into the project we are, and the current feature that's being worked on. Next, we go over to this design analysis section. This is the first part that we really go over in this tutoring process. Now, this is to sort of ascertain what the design for this specific feature is meant to be. For example, this is the movement feature of our space shooter. So you ask a couple of critical questions, like how quickly should the player's ship be able to move across the screen? Should there be instantaneous acceleration, or should there be a build-up to that? Will the player be able to improve their movement speed at any point? And will it be easy or difficult to dodge enemy shots or ships? These are all things that, as designers, we want to bring across so that when this feature is being programmed, we'll know exactly how we want this implemented, and that'll inform the decisions that we make in just a moment here. So after the design philosophy has been established, we moved on to several potential solutions. Now, it'll be the tutor's job to come up with these solutions come up with a couple of viable solutions before the lesson actually starts. And as you can see here, I've got sort of two different solutions that could be applied for movement that'll achieve the same ends, but as we'll see in a second here, they'll have different implementations that will affect the design differently. So as you can see, we've got like considerations that'll need to be made, what's going to be necessary to put in for this solution to work, and an outline that just shows, all right, these are the basic steps to implement this solution. I do this for each of the methods that I would have, and I would shoot to have 2 or 3 just so you expose students to a breadth of different problem-solving techniques that they could use here. But and as a quick little mock-up, I just went ahead and made a quick little demo here. If it loads. So as you can see, there are 2 different methods on display here that would sort of influence how the game is played. Like you can see, the one on the left has a weightier movement system, a less responsive one. Whereas the red object on the right, it responds much quicker to input. So you can see how these would lend themselves to different types of gameplay. But yeah, just you can sort of see how these things are different and how they would play into different design philosophies. After this, we would go into what I call post-implementation analysis. So after the student has implemented both of these and seen what they can do, they would just take a look at these and ask a couple of critical thinking questions just to decide which one is best for the design of the game that they're going for. And so, yeah, it would just be what do you think would work best? Where could this be implemented? That sort of thing. And also, this part would also be for encouraging knowledge retention, like saying, okay, how can you relate this type of mechanic to something you've seen in the past, just so they can connect that to a bit of prior knowledge and just really build knowledge retention based on that. And so after the post-implementation analysis, we would go into, the lesson would basically be over, we go into planning for the next feature in the feature list. And that just means, finding out what's the next step, what considerations do you want to start thinking about, or do you want your students to start thinking about before their next lesson. And, if there's any other preliminary work that needs to be done first, just to have them do that before the next session. And yeah, then after that, it would wrap up. Yeah, that's the CForge process in a nutshell. Feel free to ask me any questions that you may still have. Thank you for your time.